factoring. Factoring is the way that we take polynomials apart. If you don't have the chart of perfect squares and perfect cubes, you will probably want to get that and review the video. You will need to have your perfect squares and perfect cubes in order to do factoring. There are 3 steps that we have to follow when we are doing factoring. The first step is that the polynomial needs to be arranged in descending powers of the variable, which simply means that the highest exponents come first and the rest are arranged in order down to the lowest exponent. The second step is the one that's easy to forget. Factor out any greatest common factor other than 1. And third, after you pull out the GCF, you finish factoring the rest of the polynomial, and in the end you put the GCF back on the front. There are a number of different methods we use when factoring, and it depends on what kind of polynomial we have. The purpose of this handout is to give you a summary of all the kinds of polynomials we may encounter in this course, and to give you the methods or the formulas for each kind. There's not enough time on this video to go into detail on each of these factoring methods. I will prepare separate videos with examples worked out in detail for each of these methods. This video is simply to give you an overview. We often learn how to factor simple trinomials first. By simple trinomial, I mean trinomials that have no number out front. So we say that the lead coefficient is 1, because where you see no number, you can have an invisible 1. For these simple trinomials, we use what's called the product sum method. We simply break it down into 2 sets of parentheses. We put the x here and the x here in each parentheses, and then our job is to find numbers that multiply to give us a product, in our example of -6, that add to give us a sum of the middle number. Our special numbers are 3 and -2, because 3 times -2 equals -6. 3 plus -2 equals 1. The next kind of trinomial is a trinomial whose lead coefficient is something other than 1. In other words, there is a number out front of the x squared term. Some people call this method the AC method because we start by multiplying A, which is the lead coefficient, times C, which is the constant. So A times C gives me a product in our example of -10. Now we're looking for a sum of the middle number. Our middle number is 3. The numbers that we call the special numbers that multiply to give us -10, that add to give us 3, are the numbers 5 and -2. Using these special numbers, we expand the trinomial to 4 terms. Trinomial becomes a 4-term polynomial by splitting the middle term into 2 terms using the special numbers that we found. And then we finish the process by factoring by grouping. That is, we group the first 2 terms together and pull out the greatest common factor. We group the last 2 terms together, pull the greatest common factor out, and then we finish our factoring process. The third kind of trinomial that we will talk about is a perfect square trinomial. This is factored in a special way by using a formula. If my first sign is positive, then I have a perfect square trinomial sum. Now how do I know I have a perfect square trinomial? Well, I look at the first term and I look at the last term. If both of these are perfect squares, I probably have a perfect square trinomial. Let's check it out. We take the square root of the first term, and that goes at the front. We take the square root of the last term and put it here. All of this is in one set of parentheses, which has an exponent of 2. We have to check to see if this actually works by multiplying this times this. We double our answer. If it gives us the middle term here, we know we have factored it correctly. The perfect square trinomial difference is very similar, except that our first sign is a minus sign, and we will have a minus in our factored form. Otherwise, it's factored in the same way. The square root of the first term goes here, the square root of the last term goes here, and we check out the middle by multiplying this times this, doubling it, and see if it gives us our middle term. So 4 kinds of trinomials. There are also 4 kinds of binomials, which you will find on the first page of your handout. A binomial is a polynomial that has only 2 terms. The first one we will discuss is called the sum of squares. Sum means add, squares means we're adding perfect square plus perfect square. The sum of squares is not factorable. There's nothing we can do with it, so we call it prime. The difference of squares means we are subtracting perfect squares. That is factorable. It breaks down into 2 sets of parentheses. We take the square root of the first term, it goes here. The square root of the last term goes here. The other parentheses is the same, and one has a plus and one has a minus. So that is how the difference of squares is factored. The next kind of binomial is the sum of cubes, and that has a special factorization according to this formula. A cubed plus b cubed equals a plus b, in parentheses, new parentheses, a squared minus ab plus b squared. To find a, we have to take the cubed root of the first term. B is the cubed root of the last term, and we simply plug our a and our b into our formula, and it is factored. And the last kind of binomial is the difference of cubes, which is very similar to the sum of cubes, except that we have a perfect cube minus a perfect cube, and the signs in our formula are a little bit different. Otherwise, it's very similar. A is the cubed root of the first term, b is the cubed root of the last term, and we simply plug those into our formulas. As I said, there are separate videos for all of these methods. This is simply to give you a summary of the different formulas and methods that we have for factoring binomials and trinomials.